Good morning, students. How are you? Okay, fine. See, the physics, total 9 chapters are there. So 9 also you have learned here. No. So now I am taking which lesson related to 10th standard. That just we can revise that. Okay. That chapter 2, motion. Why I selected this lesson means 10th standard first chapter, laws of motion. First chapter you learn laws of motion. So somewhat related to this motion. So we can learn about the motion lesson. And in this video last I will give one question from 10th standard that you should study thoroughly and you have write as assignment. And here in this chapter more formulas are there. Unit are there that we can discuss in this chapter. Okay, students, listen carefully. Already you have learned this lesson. Once again revise it. Motion. So what is motion? What is motion? Do you know? So motion means a body changes from one place to another. Now my body is at rest. No, I am moving from one place to another. So what is motion? A body changes from one place to another is called motion. Okay, now can you understand about motion? A body changes from one place to another is called motion. The next one is rest. Rest, can you say the definition? A body does not change from one place to another is called rest. So now we can learn about motion as well as rest. So motion, a body changes from one place to another is called motion. Rest, a body does not change from one place to another is called rest. Now we have learned about, already we have learned types of motion. So first type is linear motion. Linear motion, circular motion, oscillatory motion, random motion. So here some types of motions are there: linear motion, circulatory motion, oscillatory motion and random motion. Beyond that we will learn uniform motion and ununiform motion. So these types of motion we have learned this lesson. So linear, what is in the linear? Linear means straight line. Straight line. Linear means straight line. So a body moves along a straight line is called linear motion. So linear means what? Straight line. A body moves along a straight line is called linear motion. Can you say circular motion? Circular motion means the circular path. It moves along a circular path. So the body moves along a circular path is called circular motion. Now oscillatory, oscillation. All of you know oscillation. So what oscillation you get? To or fro motion. Okay, to and fro motions are called oscillatory motion. The next one is random motion. Here above that 3 categories we learned. No, linear motion, circular motion, oscillatory motion. Random motion is above these 3 categories, does not fall in the random motion. The next one, uniform motion. Uniform motion, equal distance and equal intervals of time. That is uniform motion. Non-uniform motion, unequal distance and unequal intervals of time. Uniform motion, equal distance and equal intervals of time. Non-uniform motion, unequal distance and unequal intervals of time. So already we have learned these types of motion. Next, important we are going to learn means distance, displacement, speed, velocity, acceleration. So these formulas, definition and unit we can learn. This is very important. For 10th standard also very important. So you can learn it. First one is the distance. Distance, displacement. See the distance, you know, actual path we can go. So from here to Karingal, we have to go to Karingal. So any direction we can go. It's not mentioned direction, distance. But the displacement, it mentioned direction. Displacement, starting point also there, ending point also mentioned there, and the certain direction also mentioned. That is a displacement. But here distance, actual part we can move. So it does not have direction. Distance does not mention direction. But here, what under there? Starting point is there, ending point is there, and the shortest distance will be as the displacement. So the certain direction they will. Okay. But here, if you go to Karungal, some direction they will give. So that is displacement. Starting point also they will mention, ending point also mention, direction also mention. That is displacement. Example, 100-meter running race. Starting point is there. No, that will say as initial velocity. And the ending points, 100 meter means 100 meter only ending point is there. And a certain track is there. That track only we have to run. No. So that is the example for displacement. So displacement is shortest distance between the 2 points, starting point and ending point, and it is mentioned displacement. So the distance and displacement both unit is meter. So what is the unit? Distance, displacement, length also will say as a meter. Okay. So the distance, displacement, length. So 3 terms also. What is the unit? Meter. Don't forget distance, displacement and length. The unit is meter. Okay. Next we can learn about speed. Speed equal to distance divided by time. This is the formula. Distance divided by time. What is the formula for speed? Distance divided by time. The formula for speed is distance divided by time. Okay. So how we can identify speed? The bus is moving. Now according to the distance moving only we will find out the speed. So the distance divided by time. The speed is defined as the distance travelled by unit time is called as speed. Okay. Thus the definition for speed, distance travelled for unit time is speed. So how will mention the unit? What is the unit of distance? Already I told you. What is the unit of distance? Meter divided by, what is the unit of time? Second. So we can write this meter per second or meter second power minus 1. So already we have learned the formula, definition and unit for speed. Okay. The speed formula, distance divided by time. What is the unit of distance? Meter is the unit of distance. What is the unit of time? Second is the unit of time. So from that we can find the unit meter second power minus 1 is the unit of speed. Next we can learn about velocity. Velocity equal to displacement divided by time. Displacement divided by time. That's the formula for velocity. What's the formula for velocity? Displacement divided by time. So how we can say the definition? Velocity is defined as the rate of change of displacement. Velocity is defined as the rate of change of displacement is called velocity. Okay. Rate of change of displacement is called velocity. Define velocity. Rate of change of displacement is called velocity. Now we can write the unit. What is the unit of displacement? Already I told distance, displacement and length. The unit is meter. So we can write meter divided by, what is the unit of time? Second. So this unit also we can write. Here we can write meter per second or meter second power minus 1. So the speed and velocity unit same. What's the unit? Meter second power minus 1. So both unit also same, but the formula different. Distance divided by time and the displacement divided by time. You know the difference between distance and displacement. Already I told it. So all of you know the formula for speed and velocity. Okay. The next we are going to learn about the acceleration. Acceleration. Acceleration denote the letter A, small a. Acceleration denote the letter small a. If you write capital A, that's wrong. Acceleration denote the letter small a. What's the formula for acceleration? Change in velocity divided by time. So what's the formula for acceleration? change in velocity divided by time. What's the formula for acceleration? Change in velocity divided by time. You know what is change in velocity? There are two types of velocities there. See that here mentioned there, suppose 100 meter running race is there. So first you start, no, that's the initial velocity. Okay, initial means first stage, initial. And the 100 meter, when it passed 100 meter, no, that is the final velocity. So that only will say change in velocity. So we can write here final velocity minus initial velocity. Initial velocity divided by time. So we can write this change in velocity. How we can write? Final velocity minus initial velocity divided by time. So the acceleration, change in velocity divided by time. Change in velocity means the final velocity minus initial velocity divided by time. Now the final velocity, acceleration denote the letter I told you. What's that? A, small a. Final velocity denote the letter V minus initial velocity denote the letter U divided by time denote the letter T. So this is the formula for acceleration. Okay, this is the formula for acceleration. So what's the formula for acceleration? Acceleration A equal to V minus U by T. V means what? Final velocity. U, initial velocity. T, time. So the formula for acceleration V minus U by T. This formula also you can say change in velocity. But when change in velocity we are writing here V minus U. Time denote the letter T. Okay. Unit, change in velocity. I told the unit is there. No, what's the velocity unit? Meter second power minus 4. But acceleration unit meter second power minus 2. So this is different. Speed and velocity same unit, but the acceleration unit meter second power minus 2. What's the unit of acceleration? Meter second power minus 2. See, already we have learned motion, rest, types of motion, and speed, distance, displacement, speed, velocity, acceleration. So this much we have learned. This is everything fundamental. Everything when you are learning 10th standard, unit is the formula also it is there, and 11th also there, 12th also there. So what you are learning 9th standard fundamental. So this are the fundamental things only I taught today. So anyway you have to learn well thoroughly this. And the first lesson you have learned difference between mass and weight. You have learned, no, first lesson. That 10th standard also same question is there. That once again I am explaining here the difference between mass and weight. Okay, this question only I will give as assignment next class. Assignment, which question difference between mass and weight. That we can see now. So before that, once again I am explaining speed. What's the formula for speed? Distance divided by time. The unit of speed is meter second power minus 1. The formula for velocity is displacement divided by time. The unit is meter second power minus 1. The acceleration formula, change in velocity divided by time. Change in velocity means final velocity minus initial velocity divided by time. Final velocity denote the letter V, initial velocity denote the letter U, time denote the letter T. So the formula for acceleration A equal to V minus U by T. The unit of acceleration is meter second power minus 2. Okay, this is everything fundamental. Now we can learn about the difference between mass and weight. Already you have learned, once you have learned the difference between mass and weight. Once again you can learn mass and weight. So we can see the difference between mass and weight. So first one is the fundamental quantity. Fundamental quantity. See, first point what? Mass is a fundamental quantity. They are given, it is a fundamental quantity like that given. So in the place of it, what will come? Mass. It's a fundamental quantity. Why we are saying as a fundamental quantity? There is no formula for mass. Okay, no formula for mass, so we are saying the fundamental quantity. But the weight we are saying that is a derived quantity. Derived quantity. Derived quantity. So why this derived quantity means the weight has formula. What's the formula for weight? W equal to mg. So m means mass, g acceleration due to gravity. W means weight. So we are saying the derived. Suppose here mass 5 kilogram mass is there. We have find weight. Only find weight. So instead of mass we have write to 5. What's the value of g? 9.8 is the value of g. G means not acceleration due to gravity of the earth. Value only 9.8. So just you have multiply, right? You will get to the value for weight. So we are saying the weight is a derived quantity. We can derive by using the formula. We can derive. Okay, derived quantity. Now first point, mass is a fundamental quantity. Weight is a derived quantity. Second point is it is a scalar quantity. Scalar quantity. Scalar quantity is only magnitude is there is no direction. Only magnitude is there is no direction. That's only scalar quantity. Here it is a vector quantity. Vector quantity means what are there? Both magnitude also there, direction also there. That's a vector quantity. Okay. So scalar quantity only magnitude alone it is there. But vector quantity both magnitude and direction is there for vector quantity. So 2 points you have done. First point is a fundamental quantity, derived quantity. Scalar quantity, vector. These are 2 points. I'll pin out these 2 points. The next third one, the definition for mass. Mass is the amount of quantity contained in a body. Suppose 1 kilogram rice we are purchasing from a shop. Okay. So 1 kilogram of rice. Only one rice is there? No. More amount. No. Amount of quantity contained in a body only mass. So you have to write here amount of quantity contained in a body. Amount of quantity contained in a body only mass. Weight, the gravitational pull exerted on a body. Here the gravitational pull. Gravitational pull exerted from the body. That's the weight. Gravitational pull exerted from the body. Here amount of quantity contained in a body. Here gravitational pull exerted on a body. What's the unit of mass? Do you know? Its unit is kilogram. Here its unit is Newton. So its unit is kilogram. Its unit is, which unit is kilogram? Mass. The unit of mass is kilogram and the unit of weight is Newton. See the first point, mass is a fundamental quantity, weight is a derived quantity. Mass is a scalar quantity, weight is a vector quantity. Scalar quantity, magnitude alone, vector quantity, both magnitude and direction. Then amount of quantity contained in a body mass. Here the gravitational pull exerted from a body is called weight. The unit of mass is kilogram and the unit of weight is Newton. It does not change from place to place. Mass does not change from place to place, but here varies from place to place. So Earth gravitationally 9.8. Suppose Moon if you go means the gravitational force different. So here varies from place to place. It's place to place the weight will vary. Okay. So here you have written varies from place to place. Varies from place to place. Here remains same. Then remains same. Varies from place to place. Here remains same. Varies from place to place. The last one is mass can be measured using physical balance. Measured using physical balance. Weight can be measured using spring balance. So the weight can be measured using spring balance. Mass can be measured using physical balance. Important question. Difference between mass and weight. Already you have learned 9th standard as well as 10th standard also. The same answer right means you will get mark. Okay. So first point, mass is a fundamental quantity, weight is a derived quantity. So the mass is a scalar quantity, magnitude alone. Vector quantity, both magnitude and direction. The amount of quantity contained in a body mass, the gravitational pull exerted on a body is weight. So the mass unit is kilogram. The unit of weight is, what's the unit of weight? Unit of weight is Newton. And remains same, varies from place to place. The weight varies from place to place. The mass can be measured using physical balance. Weight can be measured using spring balance. Okay. So these are the points, difference between mass and weight. You have learned thoroughly this question and the writer's assignment. Once again, today what are the portions I have taught? Once again I am revising. So what is motion? What is motion? A body changes from one place to another is called motion. What is rest? A body does not change from one place to another is called rest. Okay. Types of motion you have learned. What are the types of motion? But linear motion, circular motion, oscillatory motion, random motion, uniform motion, non-uniform motion. So you know all of you, linear means what? Straight line. A body moves along a straight line is called linear motion. Circular motion, a body moves along a circular path. Then oscillatory motion, to and fro motions are called oscillatory motion. Random motion, the above the three categories does not fall in the random motion. Uniform motion, equal distance and equal intervals of time is called uniform motion. And non-uniform motion, unequal distance and unequal intervals of time is called non-uniform motion. So all of you clear about motion. And the next distance, displacement. Distance, displacement. What is the unit of distance, displacement and meter? What's the unit? Can you say? What's the unit of distance, displacement and meter? What's the unit? Meter. Very good. Meter is the unit of distance, displacement and length. Okay. The next, the distance does not mention direction. Displacement, it mentions direction. Okay. Next, speed. Speed means what? Distance traveled divided by time. What's the unit of speed? Can you say what's the unit of speed? Meter second power minus 1. The next, velocity. Velocity formula, displacement divided by time. So what's the formula for velocity? Displacement divided by time. Can you say the unit of velocity? Same as the speed. No, what's the unit of velocity? Meter second power minus 1. The next, acceleration. So acceleration, what's the formula for acceleration? Change in velocity divided by time is called acceleration. Change in velocity, what are the velocities? Initial velocity, final velocity is there. No. So final velocity minus initial velocity divided by time. So the final velocity denote the letter V. Initial velocity denote the letter U. Time denote the letter T. So the formula for acceleration A equal to V minus U divided by T. What is the unit of acceleration? Meter second power minus 2. The unit of speed, velocity, meter second power minus 1. Acceleration, the unit of acceleration is meter second power minus 2. Okay, don't forget, don't confuse this. Acceleration unit, meter second power minus 2. Speed and velocity unit, meter second power minus 1. Okay, so these are the things we have learned today. And which question assignment I told? Difference between mass and weight. Once again I am explaining. Mass is a fundamental quantity. Weight is a derived quantity. Now the mass is a scalar quantity. Magnitude alone. Weight is a vector quantity. Both magnitude as well as direction also. The mass definition, amount of quantity contained in a body only mass. The weight, the gravitational pull exerted on a body is called weight. The unit of mass is kilogram. The unit of weight is Newton. It remains the same. Which one remains the same? Mass remains the same. Everywhere the mass is same. But the weight varies from place to place. Each place change. The weight will change. So the varies from place to place. The last one is the mass can be measured by using physical balance and weight can be measured by using spring balance. Okay. Do you know what is physical balance? What is spring balance? So spring balance we can find weight, and the physical balance we can find mass. Physical balance is in the physics laboratory. Laboratory they use physical balance. Spring balance also laboratory is there. When school reopen, I will show you for the physical balance and the spring balance. Okay. Now clear it. All of you learn the difference between mass and weight assignment. Okay. So this the 9th standard book, the answer is there. First lesson it is there. Difference between mass and weight is there. So learn well. And the 10th standard has the same question is there. So only one question assignment I am giving. What's the question? Difference between mass and weight, and different and other formulas, unit, you have learned. Okay students? Okay, thank you.